Today we will learn the proof of the mirror image of a point in a straight line and also answer an example using the parametric form of a straight line. So what do you mean by the image of a point with respect to a straight line? This means that the point we know and the image required have the same perpendicular distance from the straight line and lie on opposite sides of the straight line. Also, the 2 points lie on a common straight line, or else you could imagine the straight line as a mirror and the 2 points as object and image respectively. Now let's get started with this proof. We are given a line ax plus by plus c equals 0 and a point p0, x0, y0. We are required to find the coordinates of the image of this point p0. Let the image be p dash. The point q is the midpoint of this line p0, p dash and lies at the intersection of these two lines. So using the parametric form that we learned before, we can find the coordinates of any point on this straight line as x equals x0 plus at and y equals y0 plus bt, where t is a parameter. Click this info card to learn how to get this parametric form. So the coordinates of the image p dash can be given as x0 plus at1 and y0 plus bt1, where t1 is the parametric value at p dash. To find p dash, we need the value of t1. Here, since q is the midpoint, we can write its coordinates as the summation of these two coordinates. So that will be 2x0 plus at1 over 2 and 2y0 plus bt1 over 2. Now this point q satisfies this line ax plus by plus c equals 0. So we can substitute its coordinates, that is a into 2x0 plus at1 over 2 plus b into 2y0 plus bt1 over 2 plus c equals 0. So when we simplify this and subject t1, we get the value of t1 as minus 2 into ax0 plus by0 plus c over a squared plus b squared. Now that we have t1, we can find the coordinates of the image p dash as x0 minus 2a into ax0 plus by0 plus c over a squared plus b squared and y0 minus 2a into ax plus by0 plus c over a squared plus b squared. Remember, you can't use this formula directly while solving questions. Either you prove it and then substitute the values, or simply use the method that I am going to use to solve the following example. The straight line given is x minus 2y minus 7 equals 0 and the point given is p1, 2. We need to find the image p dash. So the gradient of this perpendicular line will be b over a, that is minus 2. We know how to find the parametric form of a straight line. So we can represent this line p dash as x equals 1 plus t and y equals 2 minus 2t, where t is a parameter. So the coordinates of p dash can be given as 1 plus t1 and 2 minus 2t1, where t1 is the parametric value at p dash. Since q is the midpoint, you add these two coordinates and divide by 2. So q is 2 plus t1 over 2 and 2 minus t1. Now q satisfies this line x minus 2y minus 7 equals 0. So when we substitute its coordinates, we get the equation 2 plus t1 over 2 minus 2 into 2 minus t1 minus 7 equals 0. So then we can get t1 equals 4. So now we can find q as 3 minus 2 and also the coordinates of the image p dash as 5 and minus 6. To be familiar with this technique, try the exercises given in the description below. Now for the tip of the day. You may have noticed that we use the point q to find the parametric value at p dash. This same technique was used when finding the normal distance to a straight line. This trick is used in quite a number of problems in geometry. Since P dash has no direct relationship with this straight line, we use Q, since that is the only point which has a direct relationship with the straight line, because it lies on this straight line. If you find this a bit confusing, don't worry, you will understand this as you answer more and more problems. Comment down below if you have any questions and spread the news of this channel to your friends. Until we meet again, take care.